Alright, section 4.3 is factoring and solving by factoring. And factoring is kind of a tough concept until you get the hang of it. So to start off with some basic problems here is you always look for a greatest common factor. Okay, sometimes they won't have a greatest common factor, and then you'll move on to the steps that we're going to look at. Okay, so I'll give you 4 examples here. All 4 of these are a little bit different. Let's say we had 6 and 5x. Alright, let's say we had these 4 problems. If you notice, all 4 of these have a little bit different arrangements of the signs. Okay, we have a negative and positive, 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 negative, negative, and positive, negative. All 4 of these problems are different, but they're done almost the same. Okay, and if you notice, x squared minus 5x plus 6, it's got 3 terms, and there's a 1 out in front of this x squared. We have no GCF, so automatically we say, alright, we're going to split this up into 2 parentheses. We're going to split up our x's. And you always look to the right sign first. The right sign says they're both positive. Or I'm sorry, they're both the same. You look to the second sign, and it tells you they're both going to be negative. Last step, look at your last number, which is 6, and say what factors of 6 will add to get you 5. And the only one that will add to get you 5 is 2 and 3. The order doesn't matter, and that's your factored form. And it's real easy to check your work. Negative 2 minus 3 is negative 5. Negative 2 times negative 3 is positive 6. Real easy. Same thing here. We have 3 terms with no GCF. Split up your x terms. This one, just like the last problem, both of my signs are going to be the same, but this time they're both going to be positive. And factors of 8 that add to get me 6 are 2 and 4. Again, the order doesn't matter. Okay. The last 2, similar as well, no GCF, so split up your binomials and your x's. This time, the sign is negative, which tells me my signs are going to be different. I don't care what this sign is here right now. I know that this sign is negative, which means my signs when I factor are going to be opposite. Always. Okay? Then we say, well, what factors of 12? This time, we'll subtract to get me 4. You read right to left. What factors of 12 subtract to get me 4? Okay? So you list out your factors. 2 and 6, you can stop there, although 3 and 4 are also factors, but 2 and 6 are the only factors that get you 4 when you subtract. This time the order does matter. The signs aren't the same. Since this 4 over here is negative, you want your larger number, which is 6, to go next to that negative value. That way when you check your work, you say 2 minus 6 is negative 4. 2 times negative 6 is negative 12, which means we're in good shape. Last problem, same type of thing. Split up your x's. This is negative, so my signs are going to be different, just like the problem over here. And you're looking for factors of 15 that subtract to get you 2. And 3 and 5 is the only one that works. This time, this 2 in the middle is positive, so I want my larger number to go next to the positive. And if you check your work, you'll know that's right. 5 minus 3 is positive 2. 5 times negative 3 is negative 15. The last type of examples in this chapter is special patterns, and it's the difference of 2 squares. And you can tell these right off the bat. If you had something like this, you can tell it's only got 2 terms. It's missing that middle x value. and there's no greatest common factor. So this is how you do these problems here. Split up your x's. Your signs are going to be different because of that minus. And if you think about it, there is no x term. So really it's 0x. And you're saying what factors of 49 will subtract to get me 0? Or an easy way of doing it is to say what is the square root of 49? And that answer is 7. So now when you check your work, 7 minus 7 is 0x, and then 7 times negative 7 is negative 49. The only thing they can do different is maybe throw in a number right here out in front. So we had 4x squared minus 1. There is no GCF, there is no middle term, but this time we have a 4 out in front of this x squared. Well, it's the same concept. Take the square root of 4, which is 2. Signs are going to be different. Square root of 1 is 1. That's all you do. If you had something like this, you cannot factor. Okay, not factorable because this sign is positive. Okay, it has to be a minus sign connecting those two values. The last part of this chapter is just solving, and I'm just going to do this real quick to a couple of these problems. I'll go back up to question 1. If it said to solve these, and let's say it was set equal to 0, all you would do is take your factored form and set each of those things in parentheses equal to 0, and you would solve. Okay, so just add 2 to both sides. 0 plus 2 is 2. That's one answer. Add 3 to both sides. 0 plus 3 is 3. That's your other answer. Okay, so if it says solve by factoring, it will be set equal to 0, and you'll just set each term or each item equal to 0. Same thing here. If this was equal to 0, you'd set that equal to 0, that equal to 0, and you have 2 answers. Same thing for all the rest of these. Okay, we'll do this last one because it's a little bit different. If it was set equal to 0, you would set 2x plus 1 equals 0, 2x minus 1 equal to 0, and you would solve. Subtract 1 to both sides, divide by 2, and you get negative 1/2. Add 1 to both sides over here, divide by 2, and you get positive 1/2. And that is section 4.3.